Hello. The assignment that I got is problem set C. I'm Wasota Changrutiku, and my student ID is 633819791. In this problem set, I'm assigned to create a mealy state machine where I can detect the sequence 1001, and that will be exactly what I do. So what I first have done is that I have created my own state diagram table over here. Since we are trying to detect the number 1001, we first start at state A, where if it's where state A represents 0. If it's 0, it will repeat its own state. But if it's 1, then it will goes to B. Now B represents that the number is currently 1. So if the next number is 0, it will move on to C. But if the number is 1 again, it will repeat its own states. And then C represent that the current state is 1, 0. So if the next input is 0, it will go to state D, or else if it's 1, then it will move back to state B because B represents the state 1. And then now come to D, the current state of D is 1, 0, 0. So if the next input is equals to 1, that means that we have detected the sequence 1, 0, 0, 1. Therefore, it will output 1 over there, or else, and then it will move back to B. Or else, if the next one is 0, it will move back to A, meaning it start over. And here's the state table. After I completed this on my personal note, what I have done next is I completed the state diagram in Quartus 2. Over here, I have completed the exact same thing. That's what I described earlier. Over here, I set A as a reset state, and the reset mode is asynchronous and is reset active level. I set it to active low for no particular reason. And once this is being done, I press the button and then I generate the VHD file, which is located over here. And then in this VHD file, I did not change any code at all. I only added the comment, and here you can read the detail later in my report. Following that, I generated the RTL viewer. Over here is a simple circuit that you can see. It utilizes the DLATCH to record the state, and this is the overall things. It's a very simple circuit over here where the clock going into the clock over here, and the reset goes to reset, and the input goes into input, so on. However, what's different in this case is that what's kind of different in this case is that our reset has to go through this OR gate first, because I have set the whole reset part to be active low, so they need to go through this OR gate which acts as an inverter to make it active low. And here comes the output. Then once this is done, what I have done is I modified the given example more state machine test bench, and modify it into a test bench for our case over here. As you can see, pretty much I just remap the input and output to be W and Z, which I use to be consistent with what I used earlier. And then I created 3 test scenario. In the first case, I just randomly put in some numbers. It's gonna be some random. Okay, sorry. First, I turn on and off the reset. When it's 1, it will be turned off, and then when it's 0, it means that it's being reset again. And then what I've done is I go to create the first test scenario. First, I randomly put in some numbers where there is no 1001 pattern that I'm trying to detect. As a result, the expected outcome of this should all be 0. And in our second test case, I just input 1001, and since it's exactly the pattern that we are hoping to detect, the outcome should be 0001, where 1 signifies that we have detected the pattern. And in the third case, in the third case over here, I try to detect 1001001. In this case, it's a overlapping pattern, and our expected outcome should be detecting it twice, meaning it should be 001001. And that's exactly what I've done. And that will be all for our test bench over here. Following that, here's our simulated results. I'll zoom it in so it's easier to see. You can first see that the reset has been flipping on and off for a really brief moment. I said the nanoseconds should be very slow. And then we have the clock that's consistently running at 20 nanoseconds. And then here's our W, which is our input. So you can see that, and over here is our output. F state here indicates the current state that the machine is in, and F state, the rec F state indicates what would be the next state based on the input W. Okay, so at first when it's zero, when the input over here is zero, our current state would be let me put it like this. When the current state is equal to zero, our current state, when the input is zero, our current state is A, and when our input moves to 1, our current state is now is going to be B after 20 nanoseconds, and so on. But if I zoom out a little bit, you will see that because over here our input is following some random pattern of 001111110000, you can see that our signal here, our output here is always 0 because it's not detecting any pattern. Even though the state here moved from A, B, C, D, A, B, C, D, and so on, it's still going to be 0 because there's no pattern over there. And then starting at this part where the input goes to 1, is 1 here, and then 0, 0, and 1. So this is our test scenario number 2. You can see that our output here is also 0, 0, 0, 1. And in our third scenario where we test the overlapping part, you can see that after this one, it wait a bit, and then this is another 1, and then our input is 1, 0, 0, 1, 1, 0, 10010001, and you can see our testing result will be 001001. Alright, so that will be all for my recording. Thank you for listening.